So now we need to talk about one of the basics of factoring, which is the greatest common factor. It existed a little bit when you were dealing with factoring numbers in a pre-algebra class somewhere, but it's going to become really important to us in terms of dealing with factoring polynomials. So what is it? It says what it is right in the definition. Okay, so greatest common factor. Factor meaning it's a factor of the terms, meaning it multiplies into those terms. Common means it multiplies into all of the terms. It's common to every one of the terms. And greatest means you want to go for the largest coefficient and the highest degree. That's what it says, largest coefficient, highest degree that is possible. Now, polynomials that are completely factored are ones that you cannot factor any further, right? You've tried every single thing. Now, that's going to become a little bit more important later on, but you get the general idea. So in factoring a polynomial, we always want to do it completely if at all possible. Okay, so let's practice it. Now you want to look at the first one where it's 4x plus 8, and you want to think to yourself, okay, what could I divide away out of 4 and 8, right? You're looking for something that would multiply. Now where students get all confused is, you get so used to the double parentheses thing. You start thinking, oh, every thing I factor should have double parentheses. This doesn't have double parentheses, so I'm done. But be careful. If you do that, you're kind of forgetting the double parentheses is the most common one we do, but it's not the only thing we do. So this is one where it's much simpler than that. You look at this and you say, okay, 4 and 8. 4 multiplies to both of those, right? So divides into both of them. So 4 times 1x plus 2, right? Or if you like, it's just 4 times x plus 2. Now see if this works. You should always be able to multiply and get back what you had. 4 times x would make you 4x. Matter of fact, we really don't need this middle one. 4 times x would make you 4x, plus 4 times 2 would make you 8. If you distributed this out, you would get back what you originally had. And it's completely factored. There's nothing else that you can take out of x and 2. All right, so let's look at the next one then. We have 25x cubed plus 35x squared. So 25x cubed plus 35x squared. Now what we want to do is take out the biggest thing we can. So you start with 5, because 5 divides into 25, 5 divides into 35. But you also want the variable to the highest power possible. This first term has 3 x's to give, and this second one has 2. So if you try to take 3 out, the second term won't have enough to give you. So you have to go with the highest degree you can, which in this case is x squared. Now in the first term, that's going to leave us 5x, because 5 times 5 makes 25. X squared times an x makes x to the third power, plus 7. Because 7 times 5 makes 35, and 7 times x squared, just nothing times x squared, there you go. So it's going to make x squared, right? Because you've got your x squared right there. All right, so we're done with that one. Next. Now there's a typo in the next one, I'm sorry. This should be a squared in the middle term. I apologize. So that's a typo. It should be squared. So it's 5x cubed minus 20x squared. 5x cubed minus 20x squared plus 35x. All right, so let's see here. What could come out of all of them? Well, a 5, because 5 divides into 5, 5 divides into 20, 5 divides into 35. And then we want to go with the highest power we can. This one has 3 x's to give. This one has 2 x's to give. We need it to be common, and this one only has 1 x to give. So I can only take 1 x out. All right, so when I vacuum off a 5 and an x, what does that leave me in the first term? Well, there's 2 x's left over, so it's x squared minus, all right, now divide. You want to take 20 and divide it by 5, and you're going to get 4, right? 4 and then an x, because you took 1 x away. There's still 2 there, so only 1 is left. Now multiply and see if you can get it back. 5 times 4 is 20. X times x is x squared. And remember, there was a typo. It should be an x squared. Plus 35x, so plus 7, period. Why not x? Well, because we took away the x. There was only 1 x in that problem, and I've factored it out right there. Now, you would keep going if you could, but the problem is you can't. So if you try to do x minus something and x minus something, it isn't going to work because the only things that make 7 are 1 and 7, right? And 1 and 7 add up to -8, and we have -4 in the middle term. So this is all no good to us. We don't want any of it. Nope. We are done right here. You always want to try to keep factoring, but in this case, it won't work. All right, last one. All right, 18p to the 4th, 18p to the 4th q. Let's see, minus 12 p cubed. Oops, not print. P cubed. There we go. Q squared. Let's see, plus 30 p q to the 3rd. All right. So now what can we take out? Actually, the letters are kind of easier to see. This term right here only has 1 p to give. This one has 3, this one has 4. So a p is the largest I could do. Then q is the largest I could do there because that term only has 1 q. And then leaves you the numbers 18, 12, and 30. Now, you might look at them and say 2. And you wouldn't be wrong. 2 does go into all of them. 3 also goes into all of them. But there's a bigger number, and you always want to go for the biggest number you can, which in this case is 6. So you make 6pq times, I know, well, that will leave you 3p to the 3rd in the front, because there's 3 p's, there's 4 p's total, and we took 1 away, which leaves you 3 left over, minus 2 p squared q, because we took one of the p's away, so that leaves you p squared, and there were 2 q's here, and we took one of them away, right? We factored it out. It's right here. Plus 5q squared. Again, there was a p there, and I took that entire p away, and then q cubed, I took one of the q's away, and it became q squared. And actually, at this point, we're done because this thing that's in the parentheses doesn't factor. So we're finished right there. Now, for the next page, what happens if it's negative in front? All right, do you see what happens? The leading coefficient is negative. That's a trickier proposition, and your author just loves these. So it's negative x squared minus 2x minus 1. So what you can do is you can say, look, I want that x squared to be positive. So I could factor out a -1. If I did that, it'd be positive x squared, positive 2x, positive 1. Like that. It switches the sign of everything. Now remember, you should be able to multiply and get back what you had. So if you take -1 times x squared, you get negative x squared. -1 times 2 is -2, and so on. All right, now this is equal to -1 times, and now we've got to be able to come up with a couple parentheses, x plus x plus. All right, luckily for you, 1 is prime, so the only way you're going to get 1 is 1 and 1. Now double check that this works. First, x times x makes x squared. Outers, 1 times x is 1x. Inners is 1 times x. That's another 1x. 1x plus 1x will make 2x. And 1 times 1 makes 1 for the last. So there it is. It's this, if you want to write it a different way, because some people really like to, you could also write it as equals negative x plus 1 squared. And the 1 in there doesn't really matter. That's just for your own benefit. Okay? All right, last one. Oh, do you see how that's a -5 in front? Oh, that's terrible. Let me type that up. There it is. All right, so -5x squared y plus 15xy squared minus 10y cubed. So hopefully you notice you don't want to just take a negative. You want to take a negative to turn this front one positive. But while you're on the subject, why don't you take a -5? Because 5 divides into each of these numbers. And then y, I'll take one y, and I won't take an x because these first two terms are okay, but this last term doesn't have any x's in it. So I cannot factor an x out. All right, if I take the -5 and the y away, all that's left in this front term is the x squared. So write x squared. Now, if I factor out a -5, in other words, you're taking 15 and dividing it by -5, you're going to get -3xy. Now, double check me. negative 5, excuse me, times negative 3 makes positive 15, see? And then you have one x coming right there, and you've got a y and another y, which will make y squared. Then plus 2, because negative 10 divided by negative 5 will make positive 2, y squared, like that. Now, did you notice, and hopefully you did, that the signs all switched? This term was negative, then it was positive, and then it was negative. So negative, positive, negative turned into positive, negative, positive. When you factor out a negative like that, it causes all the signs to switch. Now, unfortunately for you, you are not done by a long shot. You have to write 5y in front, and then you got to do double parentheses. So it's going to be x and x, and they both have to be subtractions because that's how you're going to multiply to 2, but add up to negative 3. Now again, 2 is prime, so it's got to be 2 and 1, but you need to have the y's in there in order to make the y squared in the back like you want. And there you go. And just like before, if you don't want to write the 1, that's not the end of the world. If you want to write negative 5y, x minus 2y times x minus y, that's fine. And again, also the order doesn't matter, although we tend to put the y part in front. But those are both perfectly correct. All right, we are done with that section. I will see you back here for trickier factoring. Factoring when a is not 1. We'll deal with that then.